Let's say I had the rational function x squared minus 6x plus 5 and x to the third minus, oh, I don't know, 4x plus, 4x squared plus 3x. So in the denominator, I need to factor out an x, and I would get x times what? X squared minus 4x plus 3, and it would be x minus 3 and x minus 1. Does the numerator factor? X minus 5 and x minus 1. So we know that the domain is all real numbers, but x is not allowed to be 0, 1, or 3. Does everybody understand why the denominator cannot be 0 or 1 or 3? All right, now for structure, what happens at x equals 0? It's a vertical asymptote. How do I know? Because it's a discontinuity and it didn't cancel. What about x equals 1? There's a hole at x equals 1. How come? It did cancel. And then what about 3? 3 is a vertical asymptote. All right, does this function have any horizontal asymptotes? Yes, we look at the largest term in the numerator and the largest term in the denominator, and that simplifies down to be 1 over x, and if you plug in infinity, you end up with 0. So there's an HA at x equals 0. No, that's, oops, you're right, it's y. Not quite. So this is a review of yesterday, and then today we're going to focus on slant asymptotes, and then tomorrow, which is Monday, we will put everything together into one big whole. Okay? What if I had this? Let's not do 4. Let's do... Where are the discontinuities? Does the bottom factor? It does. It factors into imaginary numbers. It would be 3x squared plus 4i and 3x squared minus 4i. But no, we wouldn't factor it because the denominator is a polynomial that does not hit the x-axis, which means it never equals 0. So there are no discontinuities. The domain would be all real numbers. So the domain is all real numbers. So where are the vertical asymptotes? There aren't any. What about the holes? There aren't any. Does this have any horizontal asymptotes? Yes. I divide these and I end up with 4/9. So the HA is y equals 4 over 9. So there's a vertical, or there's a horizontal line at 4/9. Nope, no holes, no VAs. And as the graph approaches infinity or negative infinity, it gets closer and closer to 4 over 9. Now, in this graph, so if this was 1, 4/9 would be just less than half. Can a graph go through a horizontal asymptote? Yes. We just mean on the edges it's approaching. So the graph might look something like this. I'm not sure what it is, but there are no vertical asymptotes and there are no holes. So my guess is the graph is something like that, maybe upside down. I might have got that backwards. Okay? Well, what if I had let's say 2x to the third plus 3x squared minus or plus 4x plus 1 divided by 5x squared minus 6x plus 1. So let's just focus on horizontal asymptotes. Does this have any horizontal asymptotes? No, because when I divide the leading two terms, I end up with 2x over 5. And when you plug in x equals infinity, we get y equals infinity, which means as the graph goes to the right, it's going up forever. There's no maximum value. What about as x approaches negative infinity? What does the graph approach? Y approaches negative infinity. So this has a slanted asymptote. Lexi, you can't be using your phone when you're supposed to be paying attention. Yeah, you're not paying attention. It's okay. First two are free. So this has an asymptote that has the slope 2/5 x. If I draw the graph, this would be about 2/5, and I'm not really sure where that goes. I just know that its slope. So let's say it's there, then the graph might look something like this. And it's approaching that slanted asymptote. Okay? Well, how do we find the equation? We use something that you already know how to do. Two x squared over 5, then you would have a quadratic asymptote. No. Quadratic asymptotes, they exist, but you'll see equations that have them, but you won't be asked to find them. Okay, you'd probably just say no horizontal and no vertical. Yeah. So turn to page 314. And example number 6 says finding slant asymptotes. And it gives the problem 4x to the third plus x squared plus 3 over x squared minus x plus 1. Okay? And if you look at the box above, so we're on 314, if you look in that brown box, it says if we have a rational function with a polynomial on top and a polynomial on bottom, and the degree of the polynomial on top is one more than the degree of the polynomial on the bottom. So if the top is x to the third and the bottom is x squared, you'll have a slant asymptote. So if the degree of the numerator is one higher than the degree of the denominator, then you'll have a slanted asymptote. And they put that in mathematics terms, which is really hard to understand. Okay, and it says, if you divide the top function, n of x, by the bottom function, d of x, then the rational function can be expressed as mx plus b plus the remainder. Okay, so if you have an x to the third equation and you divide by an x squared equation, your answer is going to be a linear function with or without a remainder. Do you understand that? So if this is n of x and this is d of x, if I make the box and I put dx here and I put n of x on the inside, then what am I going to get here? Something linear. mx plus b plus some remainder divided by the original d of x. Right? How do I know that this is going to be linear? Right, the denominator is just missing one x. So 3x to the third divided by x squared is x. X to the eighth divided by x to the seventh would be something x. Okay? So, where the degree of the remainder is less than the degree of d of x, and the line mx plus b is the slant asymptote. So when you divide them, this is the equation of the slant asymptote, regardless of whether it has a remainder or not. So all you have to do is long division, although I call it long division. It's not truly long division. It's box division. If you divide them, then the linear portion of your answer is the slant asymptote. I'm going to put x squared minus x plus 1 on the side of the box. And then I bring down the 4x to the third. If I pull out an x squared, what's left? 4x. And 4x times negative x, negative 4x squared. And 4x times 1 is 4x. Add a column. This square and this square need to add up to be x squared. So I add 5x squared. Pull out an x squared and I get plus 5. And then 5 times negative x is negative 5x. 5 times 1 is 5. These are my remainders. This plus this needs to add up to be 0 plus 1x. And this one and this one need to add up to be 3, so I need to subtract 2. So I get 4x plus 5 plus x minus 2 over x squared minus x plus 1. Okay, everybody remember how to do that? But I don't care about the remainder. Why not? Right. Because, so the reason is, this tells me what about my slant asymptote? That's where it crosses the y-axis. So we cross the y-axis up here at 5. What does this tell me about my slant asymptote? That is the slope of the slanted asymptote. Okay? And what does this stuff do? It's very, very, very small. Right? The bigger we get, the bigger x is, the smaller it is because it's an x divided by an x squared. So it is so small, we can just simply throw it out and say the slanted asymptote is 4x plus 5 because that remainder is such a small piece of the function. Great question. Why did I even do the remainder? I wanted to see if anybody understood that tan box before I finished. Once you get to here, you can stop. So I didn't need any of these squares. In fact, I didn't even need this square, the bottom left one. As soon as you get your constant, you don't care if there's a remainder, so you can go ahead and stop. Okay. Look at yeah, you wouldn't need it. All right, let's do another one that has a slanted asymptote. All right, let's do x to the third minus 3x minus 4 divided by 2x squared plus 4. It's not a number. I just pulled it from the book. So I want to find the slant asymptote. Does this have any vertical asymptotes? When does the denominator equal 0? Never. 2x squared plus 4 is never 0 or a negative number. I put 2x squared plus 0x plus 4 in the box. And then I put x to the third here. Oh, this is going to be kind of weird. Let's make that a 4, just for fun. No, I don't want to. this looks like more fun. What happens when you pull out a 2x squared from x to the third? 1/2 x, right? So what I'm asking is this times this needs to equal that. So this would have to be 1/2 x. And 1/2 x times 0 is 0x squared. And really all I need is this one. So 0x squared and this one need to add up to be 0x squared. So this is 0x squared. And this is 0. And I don't need anything else. So the slant asymptote is y equals 1/2 x. And it goes through the origin. Yep. It does not have, the y-intercept is 0. Okay. So look at page 322. We are going to do 322A, problems 17 through 28 all. In the first set, you are just going to find the slant asymptote. So all you have to do is divide. In the second set, you need to match the graph with the function, and you can do that by finding the asymptotes. The slant asymptotes, the vertical asymptotes, the discontinuities, that sort of stuff. And if you find that information, then you can look and identify which graph is which. All right. Good luck.